Hi, Algebra 1 students. These notes are on the quadratic formula, which is Eureka lessons 14 and 15 in your Module 4 workbooks. So the big idea is that this quadratic formula is a new method to solve quadratic equations when other methods do not work as well. So let's write that down. So the quadratic formula is a method for solving quadratic equations when other methods don't work so well. So to give you an idea of what I mean by the other methods not working, I'm going to give us a quick example. So my example is negative 2x squared minus x minus or plus 4 is equal to 0. So we know the other methods we have for solving quadratic equations are factoring, completing the square, or square roots method. We can't use square roots method here because we have a bx term. So if you have a bx term and an x term, you know you can't use square roots. So then if I try to factor here, I have a is not equal to 1. So I'd have to multiply a times c and set up my x. And that would be a times c is negative 2 times negative 4, which is negative 8. And I'm wondering what multiplies to negative 8 and adds to be negative 1. So that would be 1 and negative 8, or negative 1 and positive 8, or 2 and negative 4, or negative 2 and positive 4. So if I kind of think about, do any of these combinations add to be negative 1? The answer would be no. So the idea is factoring does not work. It is not possible to factor. So then I could move on to completing the square. So if I take my equation negative 2x squared minus x plus 4, set it equal to 0. So the first step would be to subtract the 4 over to the other side. Now I have negative 2x squared minus x. Then because a is not 1, I would take out that negative 2. And I get a 1/2 x. And then I'd have to start to think about how do I complete my square. Like what would I have to add there? And I already have a 1/2 as my b value. So I'd have to take that, divide it by 2 again, and then square it. So I start dealing with these kind of messy fractions or decimals, and I don't really want to do that. So this would be another situation where if I don't want to deal with the decimals and fractions, quadratic formula is a great alternative. The idea is that the quadratic formula will always work if you have a quadratic equation in standard form, which is ax squared plus bx plus c is equal to 0. Then you can always plug into x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And the other, I'm going to give you one other form of it, which is dividing that 2a into both of the terms on the top. So making two separate fractions. So the other, we have x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And the first version we're going to use more often, but the second one is useful if we think about this graphically. Because if you remember, if you see in the second version, we're able to clearly see the negative b over 2a, which should be familiar because that's the axis of symmetry. So graphically, I'm just going to sketch in my axis of symmetry. and that's my negative b over 2a. And then the idea of adding and subtracting the b squared minus 4ac over 2a is that if I add, I kind of am going from my axis of symmetry over in one direction, and it takes me to my first x-intercept. And remember, x-intercepts are the same as the solutions to when we set the equation equal to 0. And then if I subtract from negative b over 2a, that takes me over to my other y-intercept. So the idea is if I'm adding here, I get to 1. And then the subtraction gets me to the other. Okay, so let's take a look at an example. So our first example, I'm going to write steps along the right, and then we will go from there to solve our example. So the first step is going to be to put the equation in standard form if it isn't already. So in our case, I don't have to do any work here because I already have it equal to 0. So I'm all good. Sometimes you'll have to move some things around. My next step is going to be to identify our A, our B, and our C values. And I'm going to do this in 3 different colors. So I'm going to say A would be -2. Be very careful with your signs here. You don't want to forget the sign in front of the number is a part of the number. So for B, I need to take -10. And C would be -8. So for my next step, I'm going to plug these values in to the formula. And it's very important here that you must use parentheses. If you do not use parentheses, you'll be much more likely to make a mistake. People think quadratic formula is easy, but they forget that there's a lot of places where you might make a potential mistake, and parentheses will prevent that. So I'm going to set up my formula, but I'm going to leave some space, like a couple of lines directly above it, because I'm going to work up when I simplify. So I'm going to start by just setting up my parentheses. So I know it's negative, what I plug in for B, plus or minus the square root of something squared, that's my B value, minus 4 times A times C. So I'm just kind of setting up my parentheses all over 2A. And now I'm going to go back and plug in. So first of all, I know I have negative B, so I'm going to plug in -10 into the first set of parentheses, plus or minus the square root of B squared, -10 squared, minus 4 times A. A is -2 times C, which is -8, all over 2 times -2 for A. Okay, so from here I'm going to start my fourth step, and my fourth step is going to be to simplify using order of operations. And to do that, I'm going to say we should work up. And I'll show you what I mean by that. So what I mean is that instead of having to rewrite the entire equation, formula every single time, we're going to work up above the square root to simplify what's in the root first, and then continue from there. So starting with what's inside my root, I know I have negative 100 squared, negative 10 squared, which is positive 100. And now this next part, you want to be extremely careful with your signs because this is a place where people always make mistakes. So I'm doing negative 4 times negative 2 times negative 8. So first I'm just going to think, will that product be positive or negative? I'm wrapping in the negative with the 4. So I have a negative times another negative. That should be positive, but then times a third negative would again go negative. So I know that whatever my product is, I'm going to subtract it from 100. So now that I know my sign, I'm going to just do 4 times 2, which is 8, times another 8 is 64. So it should be negative 64, or 100 minus 64. Now from there, I'll do my subtraction. 100 minus 64, that is 36. And sometimes you'll get what's a perfect square inside of your square root, in which case you can take the square root of 36 and just get 6 outside of your root. So now that I've kind of worked up, so I'm just going to kind of put a little note. This is our working up step and of number 4. And now I'm going to continue below to finish the problem. So below, I now have negative 10, which is positive 10, plus or minus. Everything inside of my root just became that 6, all over 2 times negative 2, which is negative 4. So since I got a whole number inside of my root, at this point, I can actually split it and calculate the plus and the minus to get an exact value for x. So in one, I'm going to get positive 10 plus 6 over negative 2, which is over negative 4, which is 16 over negative 4, which is negative 4. In the other side, I'm going to have 10 minus 6 over negative 4 as my other x value, which is negative 4 over negative 4, which is positive 4 over negative 4, my bad, which is negative 1. So then we have two solutions, x equals negative 4 or x equals negative 1. Now, before we move on to the next example, I want to bring these solutions back to the thinking graphically, because this is actually the graph of the function negative 2x squared minus 10x minus 8. And we just solved the equation 0 equals negative 2x squared minus 10x minus 8. And once we plugged into the formula, right, we saw we had 10 plus or minus 6 all over negative 4. And now I'm going to specifically split that negative 4 for a moment while we think about this graphically. So we have 10 over negative 4 plus or minus 6 over negative 4. And if I simplify that by dividing by like creating the fraction, so 10 divided by negative 4, I know is negative 2.5 plus or minus, and then 6 divided by negative 4 is a negative 1.5. Okay, so bringing this back to what we were looking at before then, we know that negative 2.5 is my axis of symmetry, right? And we can see on the graph that this is exactly at negative 2.5. And if I add to negative 2.5, or we could say like I subtract the negative 1.5, that's like adding 1.5, that takes me to my first x-intercept of negative 1. And if I subtract 1.5, that's going to take me back to my second y-intercept at negative 4. Sorry, x-intercept at negative 4. So we see the relationship between the graph and the solutions we get, as well as the relationship between the parts of the formula and the parts of the graph. So now let's look at the next example. I'm not going to write out the steps again, but I'm going to number them so you can kind of go back to those steps. So we have here x squared is equal to negative x plus 4. So this is not in standard form. I'm going to get it into standard form by subtracting x squared over. It doesn't matter which side of the equation the 0 is on. So it's really just a matter of what would you have to move the least terms to get the 0 on one side. So since x squared is by itself, I'll move it over to the side with the other two terms. Okay, so my second step is going to be to identify my A, my B, and my C. A is -1. B is also -1. And C is +4. So now it's time to plug into the formula. I'm going to do that on the right, but I'm going to leave some space above it. So first I'm just setting up my parentheses. And now I'm ready to plug in. So I know I'm going to start by doing x is equal to -b. So I'll have -1 plus or minus the square root of b squared, -1 squared, minus 4 times a, which is also -1, times c, which is 4, all over 2 times a, which is -1. So from here, I'm going to work up. So I'm going to do step 4 above first, where I get 1 squared is 1. So now I have minus 4ac. So I have a -4 times a -1 times a +4. So negative times negative will be positive times a positive will still be positive. So I'm going to put a plus sign there. So now I'm going to basically just ignore the signs and just multiply the numbers because I already know the sign should be positive. So 4 times 1 is 4 times another 4 is 16. So now I have the square root of 17 here. And now I'm going to come back down and continue to simplify to my answer. So I have -1, which is a +1, plus or minus the square root of 17, all over 2 times -1, -2. So in this case, what's inside of my square root, 17, is not a perfect square. So I can't really do any more simplification. So this is the precise answer. But what I could do is approximate my answer by plugging it into the calculator. So if I plug into my calculator 1 plus the square root of 17 divided by -2, then I get my first approximation value, which is -2.56 approximately. So I'm able to get an approximate answer there for the first x value. And then the second one, sorry, just to be precise here, like first, initially, these are regular equal signs, but then once we get the decimal, I'm using the squiggly equal sign. So my second one would be 1 minus the square root of 17 over -2, and this would give me approximately 1.56. So now I have the precise answer and the approximate answers. I have one more example for you guys. So it is 12x is equal to -x squared minus 4. So step 1, I'm going to get this into standard form. Again, it doesn't matter which terms you move over. So my step 1, 12x is equal to 9x squared minus 4. I'm going to subtract that 12x over and then make sure I order my terms correctly. I want the x squared term first, the 9x squared, then the x term, -12x, then the 4, -4. So my next step, I'm going to identify A, B, and C. I'm not going to color code this time, so because you don't necessarily need to color code each time, but it's always a good idea to kind of help us see and not make a mistake. Okay, so A is -9, B is -12, C is -4. Now I'm ready to plug in to my formula. So I have negative parentheses, plus or minus, b squared minus 4ac all over 2a. And now I'm plugging in. So for b, I'm doing negative 12 squared, a negative 9, c negative 4, and on the bottom I have a negative 9. So from here, I'm going to do my step 4 where I work up. And I get the square, negative 12 squared is positive 144. And then the second part I see is negative times negative times negative, which will still be negative. And 4 times 9 is 36, times another 4 is 144. So something interesting happens here, which is that the number inside the root cancel, right? So we get the square root of 0, which is just 0. Okay, so this kind of yields a special situation where I have this is x is equal to negative 12 is positive 12 plus or minus just 0 over 2 times negative 9, which is negative 18. So in this situation, if I add or subtract 0, that's not really changing anything. So essentially, I only have one solution here, which would be 12 divided by negative 18, because the 0 isn't changing anything. And then I know I can simplify this by dividing by 6. And I get 2 over 3, negative. So now I know x is equal to negative 2/3, and that is the only solution. So just quick note, graphically, the idea of there being only one solution would be that there's only one x-intercept at negative 2/3, and that x-intercept is also your axis of symmetry. So we get something like this, where we have our axis of symmetry at negative 2/3, and that is also the solution. All right, guys, so we're going to be practicing using the quadratic formula next time in class. See you then.